Combinatorics are important for studying probabilities as well as for studying exponentials and logarithms. This slide deck is divided into 3 videos. In this video, we will look at permutations and factorials. In the next video, we will describe combinations. And finally, in the third video, we will derive the binomial theorem and use it to make our first acquaintance with small parameter expansions. The purpose of the following graphical exercise is to introduce factorials. How many ways can we arrange 4 distinct pieces of candy in a row? At how many positions can we place the first piece of candy colored blue? We can place piece number 1 in the first slot all the way to the left, in the second slot, in the third slot, or in the fourth slot all the way to the right. We have identified 4 places where we can place the first piece of candy. In each of these cases, the second piece of candy, colored green, can now only be placed in 3 possible positions: left, middle, or right. How about piece of candy number 3? There remain 2 unoccupied slots. The yellow piece of candy can be placed in 2 places. The fourth piece of candy, colored orange, can only be placed in the remaining position. Its location is chosen by default. There are 4 times 3 times 2 times 1 equals 24 ways to arrange 4 distinct pieces of candy in a row. There are 4 places where we can place the first piece of candy, 3 places where we can place the second, 2 places where we can place the third, and 1 place in which we can place the final piece of candy. 4 times 3 times 2 times 1 equals 24 ways to arrange 4 distinct pieces of candy in a row. This kind of product is common in studies of probabilities, and it's also cumbersome to write. For both of these reasons, it's convenient to introduce notation. The exclamation mark after a number is read as factorial, and it's an instruction to calculate the product of the number, that number minus 1, that number minus 2, and so on in steps of 1 until we reach 1. Owing to the way that products like these tend to appear in applications, it's convenient to adopt a convention in which the products are taken out to 0 factorial and in which 0 factorial is defined as 1. In this video, we have graphically studied the permutations, meaning the ways, in which we can arrange objects in a row if all objects under consideration are distinct. We introduced a symbol, the factorial, to organize our calculations. In the next video, we will learn how to count the numbers of arrangements of objects in a category of situations in which not all the objects are distinct. The arrangements we will study are called combinations.